So I talked about a solution. I said a solution is a solute that changes state when added to a solvent. But what's actually happening when it dissolves? So this is going to talk about what's actually happening from a microscopic level. So here I've got my solvent, my little solvents, and here's the solute. So the solute is going to be attracted to the other solutes. So these solute molecules are attracted to each other. So for it to separate, to dissolve, this solvent has to come in and kind of pull it away. So the only way that it's going to dissolve is the solvent's going to kind of come in and pull one of those solute molecules away so that, and break this solute to solute interaction so it'll dissolve. So here's kind of an example. So NaCl, salt. You have your Na plus and your Cl minus. The solute-solute interaction is because there's a positive and a negative. That anion to that cation. That's an ionic attraction that we talked about, ionic bonding. Okay? So for my water to dissolve my salt, my water has to come in and pull the Na plus away from the Cl minus. So if the water can come in and pull it away, then the salt is going to break apart and then dissolve. Okay? But this only happens if this is really strong. This has to be strong enough to pull it away, or it won't happen at all. So here's kind of a picture. Here's NaCl. So you got my Na pluses, my Cl minuses. And so the water's going to kind of come in and pull it away, pull it away. But we want it to stay separated. If it goes away, but then they feel each other, it might try to come back. So what happens is these waters do kind of like a water hug. And so it comes in and it surrounds it. Now remember, water is a polar molecule. So that means it has partial negatives and partial positives on it because of those dipoles. And so because it has partial negatives and positives, the negative side is going to orientate to this positive so that you get a positive and negative attraction. Okay? So it's going to have that positive and negative attraction come in. But this is a partial negative, where this is a real negative. This is only a partial negative. So when it comes in, one of these waters isn't going to be enough to pull it away. So that's why you're going to have more than one water. So if you look at all the positives, all these partial negatives are pointing to it. If you look at the negative, the water molecule turns so that the partial positives, see the partial positives were the white hydrogens. The white parts, the hydrogens, are now facing in, okay? So it takes more than one of my waters to be able to pull away. See, so two of them come in when waters are coming in, it's gonna pull away, and when it pulls these all away, then your salt is going to dissolve. And so that's what's happening when I'm dissolving a solute, specifically an ionic compound, within my water. All right, now we're going to talk about how being able to dissolve and how to break apart like this creates a type of characteristic. And so our next lecture, we're going to start talking about electrolytes and non-electrolytes.